just...
You just let me know.
I don't want to knock over the thing in haste while you're standing there. Just cut this part out.
Make sure this works. We're good.
This is a really long minute.
Yeah, this is a long minute.
Sorry, bro.
You just call me bro?
Yeah. It's better than some of the
It's
things
okay,
you've
bro.
called me. Wow.
Let's just drag it along.
This is a
Time is
really
relative. Time is
really long minute. I know, time's not even real.
yeah,
What do we care?
relative concept.
Okay, go.
Okay. Okay. So these are the Rincon Mountains. Well, they're not actually the Rincon Mountains. These are, but for educational purposes, these are the Rincon Mountains. The Rincon Mountains are located in Saguaro National Park East in Tucson, Arizona, where we all call home. And much like many other mountain ranges, the Rincon Mountains have geological formations known as watersheds. This is what a watershed looks like in real life. So as you can probably imagine, when it rains, water is collected in these watersheds and pulled downstream by gravity. And within a watershed, we have pools known as teñajas. And teñajas are prominent in arid climates such as the Sonoran Desert, and they are indentations in the bedrock created by flowing water over long periods of time. These teñajas make for great homes for indicator species such as the Lowland leopard frog, where they reproduce. Now, unfortunately, when wildfires occur on the Rincon Mountains, among other mountains, sediment is loosened and uplifted. When monsoons follow these wildfires, sediment is pushed downstream, much like water. So, rather than the teñajas being filled with water for making for a great environment for many species to reproduce and inhabit, they become filled with sediment. This process is called sedimentation, and it is the very cause that led to the expiration of the lowland leopard frog in the Rincon Mountain district. So this had repercussions throughout the district, but specifically, Wild Horse Canyon and Loma Verde Canyon were the most impacted, and this is where we saw the greatest destruction of the population, and they don't exist in that area right now. And this occurred specifically due to a succession of fires between the 1990s and the early 2000s. And essentially, this area was the most impacted just because of where they are relative to where the fires occurred. So, even though the lowland leopard frogs have not naturally repopulated these watersheds, there is an effort by Saguaro National Park to reintroduce these frogs called the Lowland Leopard Frog Reintroduction Project. They do monitoring in certain areas and have attempted reintroduction in the watersheds that I've mentioned. So with that said, we haven't seen significant success with reintroducing these frogs, and I'm asking myself, why is that? I'm guessing that it has something to do with the pools within these watersheds specifically, so if we look at a smaller scale. So I'm asking myself, why do some pools recover from sedimentation at a faster rate than others? And furthermore, how is sedimentation impeding with the reintroduction of the lowland leopard frogs? So without further ado, I present to you my findings of my study, Down and Dirty in the Rincons, the correlation between sedimentation post-wildfire and the Lowland Leopard Frog Reintroduction Project by Maxine Polson, me. So my research inquiry began with two resources that were handed over to me by the head of Department of Geology at the U of A, Dr. Uberg, who really helped me find direction and find sources during this process. She directed me towards a source called Post-Wildfire Sedimentation in Saguaro National Park, Rincon Mountain District, and the Effects on Lowland Leopard Frog Habitat by John Parker, published in 2006, as well as monitoring of sediment volume in bedrock stream pools in Saguaro National Park between 2005 and 2013, published by Carol O'Brien in 2015. So with that said, in simple terms, the first source looks at those really first initial results of sedimentation after those fires, and then Carol O'Brien, she looks at how much sediment have been in these pools in more of a long-term since then, relative long-term. And so with my study, I want to create connections. I wanted to create connections between these two sources and answer the two research questions that I mentioned prior. So why are some pools more affected by sedimentation, like at a faster rate than others, or why do they recover faster than others? And how is sedimentation affecting the reintroduction project? And the reason I want to look at that is because hydrologists and biologists are the ones that are kind of taking the front lead with this project. So I just think that there's aspects of sedimentation that still need to be understood to better help this project. So my hypothesis for the first question is that some pools recover from sedimentation faster than others because pools with a highly inclined geomorphic makeup create higher energy flow, thus moving denser quantities of sediment outside of the pool. Now I realize that I used some terms there that many of you might not be familiar with. In terms of my study, geomorphic makeup just means how is the bedrock affecting the incline of the pool. So is it really steep, causing water to move really fast, high velocity, or is it a little less inclined, creating a slower flow of water? And that's essentially what that means. So with that said, the hypothesis for my second research question is that pools with high energy flow will create the most ideal conditions for lowland leopard frog reintroduction because high energy pools are the most resilient to sedimentation. So, for my project, I had two mentors that helped me during my data collection process, and I truly could not have done it without them. First, I had on my side Don Swan, who is the Saguaro National Park biologist, and also one of the lead directors for the Lowland Reintroduction Project. In addition to Don Swan, I had Lauren Ballinger, who is a next generation ranger for natural resources, who was with me during a lot of the field work. So just for everybody's peace of mind, don't worry, I did follow ethical guidelines. When I was conducting data collection within the field, nothing left the park with me, A, because I didn't have the permits to do so, and B, I did not leave anything in the park, when I left for the day. Furthermore, I did not leave or go off trail unless I was A, with Don or Lauren, or B, given permission by them to do so. So, we have our first research question. Why do some pools recover from sedimentation at a faster rate than others? Well, I figured we'd have to look at multiple different traits of sediment to come to a conclusion for this answer. So to begin with, I looked at the geomorphic makeup of the pools, which we talked about prior, and I looked at the sediment profile of the pools, which essentially just means, what are the particle sizes within the pool? Is the pool primarily made up of small particles? Is it primarily made up of big particles, or somewhere in between? And finally, I looked at volumes, so that way we could do comparative analysis from Carol O'Brien's study to see how much they've recovered in the sense of volume since her study, which was published, over 10 years ago. And by exploring these three traits, I can make conclusions about my second research question, which is how sedimentation is impeding with the reintroduction project. So, when doing my data collection, I picked various pools to pull data from, and I picked these pools based on how much the national park has done research in them already. So the way that the park does this is they have labeled pools. At the bottom of the watershed, lowest in elevation, you have your smallest number. So in Wild Horse Canyon, 4 or 5 up to 15 feet. And then the same concept in Loma Verde, starting with AB2, 1, 2, 9, and 11. And then depending on what aspect of my methodical design I was working on, I had to pull random samples from the pool to make sure that there was equal representation. So to do this, we created a coordinate plane by length and width of the pool, and then from that coordinate plane, we would pull random coordinates, and we would just use a random number generator and put in those measurements to make sure that we had a full representation of the entire pool. So the first aspect was energy flow. Now, to record energy flow, I went with more of a qualitative approach. I merely just took observations every time I went out in the field, and I made note of, how steep are the pool sides of these various pools. So from those observations, I gathered that there is a relatively equal amount of representation of different forms of energy flow. So some pools have really high energy flow, some have really low, and some were somewhere in between. The second part, as I mentioned, was sediment profile, looking at the particle sizes within the pool. So the different categories are silt, sand, gravel, rock. I began with 250 milliliters of sediment, and then I would sift it through various sifting devices, aka kitchen utensils from my house. So I began with the smallest particle sizes with the strainer, then took the remainder of that sample, put it through the streamer, and then the remainder of that, put it through the skimmer, and that would give me my next two categories. So like I said, there were 4 categories total. There's some pictures of sifting in action. And then this looks like a jumble of numbers to you guys. That's what it looked like for me as well. This essentially just shows that we have, 5 samples from each pool, and then they were averaged to find, the categorization of particle size. And then for the Loma Verde Canyon, these were my results. As you can see, pools, let's see, so 6, we had just about half of small particle size, with the blue and the red being silt and sand, our smallest sizes. And then the top is the largest size, so green. And then same thing for Wild Horse. We have for pool 4, about half, and then pool 15C is a very large pool, so we had primarily small sizes.
Use your stick.
Oh,
you forgot
my stick, I'm so sorry. Oops, my time, okay.
Your time is great.
Anyway, so the last part of our data collection process was the volume of sediment in the pools. Now, as I'm sure you've concluded by this point, is that we were doing field science. And field science is, you can't control every variable like you can in a lab, which means that we took multiple different approaches to find the same answer depending on the pool. So some pools had, they were fully submersed in water, some had no water, some had partial water, some had water, but we didn't want to disturb organisms, so we had to take multiple approaches. For pools that were completely submerged or not submerged at all, and we weren't worried about disruption, we would level the sediment to kind of create a plane. And then in others, we would pull sediment, or we would pull samples from the sediment line, if the sediment was above the water line, down to the plane of water. So that would look something like this, or in some circumstances, we would just dig holes, and then it would fill with water, and then we'd measure that from the sediment. But point being, no matter what approach we took, we have contours of these pools where we put that data in to get us the multi-year analysis that is also used in Carol Bryan's study. So these are numerical data starting from 2005 up to the present time, and then this is a visual analysis. So we can see that most of the pools, all the pools in Loma Verde, have begun to recover. They had a stark recovery, initial, after, and then since then, gradual. And as we can see, pool 6 is one of our steepest in recovery. And then secondly, for Wild Horse, there isn't a ton of multi-year analysis from the park for Wild Horse, so we were more limited with this. Pool 15 was the only outlier where we saw an increase, and I'm not sure why that is. Maybe somebody should look at that. So, was hypothesis 1 proven? I would conclude that yes, hypothesis 1 was proven. We can see that pools with high energy flows, such as pool 6, did have one of the most intense decreases of sediment over time. Furthermore, if we look at our particle sizes, the correlation between particle size and energy flow was somewhat there. So, for example, pool 6, where's pool 6? Right here. It does have about more than half of small particle size. Same with pool 4, which was high energy. And then there were some tribulations with that, where there were pools that didn't necessarily have higher energy flow but had smaller sizes. So just kind of depends. So furthermore, was hypothesis 2 proven? The answer is maybe, and that's where I would say that maybe a future researcher should come in and do some evaluation. For example, I think that variables such as elevation, where the pool is relative to the watershed, is something that could be explored, and something that I wish I could have explored, but we had limitations with resources and time. I think there's more aspects of hydraulics that I just don't understand because I focus primarily on the geological aspects of the watersheds. And finally, there's always variability in pool conditions, whether it's weather, other species, climate change, whatever it may be. There's a lot at play when you're working with science in the environment. So I conclude that Pool 6 and Pool 4 would create the most ideal conditions for reintroduction. In fact, prior to my study, the park did try an attempt to reintroduce frogs into Loma Verde Pool 6. It wasn't successful the first time. However, more recently, they've tried again, and I'd like to believe that maybe it's because of the results of my study that they went through with that. So there were some limitations, of course. The first one being, I was robbed. My car was broken into. I really wish that I had locked my car, but I didn't. And they took my backpack, and it had my some data from about 6 hours worth of field work, and it also had my sifting devices, which was not great because I had to replace those, and they're not perfect because they were just random items from my kitchen. So it wasn't great, but it was good enough. Secondly, I wish that I had also looked at density as well as volume when looking at particle sizes. I think that would have helped with my margin of error, because there was a margin of error with volume of sediment. The margin of error being that the volume would change depending on how sifted the particles were. And finally, it's field science. We can't control every variable in a lab. So applications, why does this matter? Well, climate change. We need to take initiative as species are dying off, and fires are getting worse in severity because of climate change. Future management for the parks. Even if the information that I gathered from the study isn't necessarily used in Loma Verde or Wild Horse, it can be used with future exploration throughout all of Saguaro National Park. And further, youth involvement. We are the future, and we are the people that are going to help with combating climate change and the conservation and preservation of Saguaro National Park East and West and all. So we should get involved. So thank you.
Okay. How did your initial exploration of the scholarly conversation lead to your final research question or goal?
Okay. Can you repeat the question?
Yes. How did your initial exploration of the scholarly conversation lead to your final research question?
Okay. So when I began my project, I knew that I was interested in the geological aspects of our climate, specifically here in Tucson, Arizona, in the Sonoran Desert. I began with an interest in the Sky Islands, which is this concept that we have a completely different climate happening not far much above us. And that was as a result of geological activity way before our time. So that's where I began. And I wanted to do the Rincon Mountains because they, to me, were just more unknown than, say, like the Santa Catalinas, where there is a lot of research being done and there is a lot more human activity on that mountain range. However, finding research on the Rincon Mountains specifically was hard to do. I had a really hard time finding sources on that mountain range, which is why I reached out to Ann Uberg at the U of A, who kind of really helped me understand my initial inquiry of what's going on in that area. So I would say doing my initial research, coming across Ann Uberg, and then taking what she gave me and reaching out to Dawn. That's how it shaped my project.
Okay, so then how does your new understanding address a gap in the scholarly conversation?
It addresses a gap because even though we understood that sedimentation was the cause of the disruption for the lowland leopard frog population, sedimentation and wildfires is what caused their extinction in this specific area. It wasn't completely apparent why. Why is this process happening? Why is it more prevalent in some pools in the same exact watershed than others? And I think that concept is completely completely unknown still. It's very obscure, and I think that the traits that I looked at, amount of sediment, particle size, geomorphic makeup, these are like just really the beginning. It's just scraping the barrel. There are so many variables that still need to be looked at, but I think it did help with the literature and understanding that there is a correlation between energy flow and sedimentation.
What was the most important research skill you developed as a result of this process, and how might you apply it to your future endeavors?
The most important thing that I gained from this was learning about like outreach and learning to communicate, because my project would not have been possible. I mean, I'm sure it could have been possible, but I wouldn't have gotten as much out of it as I did had I not, reached out to Anne, and then, reached out to Dawn and Lauren when she gave me the opportunity to do so. And I'm going to be attending Montana State University in August, so I'd really like to take what I've learned from this project and pursue research in hydraulics and geology there in the Rincon Mountain, or the Rockies there. So that's what I'd like to do with this research.
Very good. Yeah. Okay, Maxine, who's the basket for?